Hi, we're here to tell you all about the physics of car design, so sit back and enjoy the show. So basically the question we are going to be focusing on is, what aspects of car design play into physics? How is it all related? What physics concepts could be still added on to make car designs more efficient? That is what we are basing our discussions on. One more thing. We will be looking at this from the perspective of the Mustang 1968 GT500 and the Bugatti Veyron 2014. Just so you know, I'm totally in love with the Bugatti Veyron. It's a very nice car, very fast speed, and I feel the Mustang just doesn't stand a chance. While driving, when a car is accelerating, all of the car's weight is directed towards the back. This causes the front wheels, on a really small and unnoticeable scale, to lift off the ground. This creates left grip on the front wheels, and could cause the understeer, meaning that the car does not turn enough at a corner, leading to a crash or steering off the road. Furthermore, when a car is braking, the opposite happens. Weight is focused more on the front tires, causing the back tires to lift slightly, and this in turn leads to an oversteer, obviously the opposite of an understeer. This is when, at a curved road, the car overturns and basically spins around, sending the car off the road and probably into a crash. Now let's watch a video to help you all better understand exactly what I'm talking about. Nowadays, when cars are designed, the CG is taken into consideration to avoid these situations, with the role of other factors such as chamber thrust, lateral force compliance steer, and self-aligning torque. The manufacturers are developing new ways to balance the forces at the CG at all times while driving, and this has drastically reduced the amount of accidents associated with driving around curves. Now, drag is not the only factor to be considered. Just as Precious said, aerodynamics involves the force of lift as well. Now, in cars, lift may not be very applicable. In fact, it's extremely dangerous. So in order to maintain better control for steering and braking, modern cars are designed so the wind exerts a downward force as their speed increases. However, increasing this downward force increases drag, which in turn increases fuel consumption and limits speed, so these two forces must be carefully balanced. Now, not only have manufacturers been able to design cars where lift and drag are carefully balanced, they have also been able to do this and still have good-looking cars. Take, for example, the Veyron. It's one of the first model cars to use movable wing-like airfolds or rear wings to adjust the downward force of the air on the car. This is a concept that originated from racing cars, and in the Bugatti, it aids in acceleration and braking. It is also noteworthy that many of the same aerodynamic principles used in racing also apply to regular cars and trucks. Automotive engineers use computer simulations and wind tunnel experiments with scale models and actual vehicles to fine-tune the aerodynamics of the automobiles so they generate the optimum amount of downward force to the front and back wheels with the least possible amount of drag. Thank you for watching. Have a great day.